Hey everybody, welcome to Bill Sky the Rust Guy, another video, and this time we're going to be talking about the match statement in Rust. And this is a continuation of the if-else video that was previous to this. And the match statement is basically just another way of asking questions. But it is very much related to the switch statement, which is in C and C++, and I also believe in Java, but it has many more capabilities than the standard switch statement. So let's get right to the code. Okay, so I'm going to go ahead and, again, I'm on Linux here, and I'm going to go ahead and create a new project. We're going to call this Rust Match. I'm going to use cargo. Okay, and let's see if it's there. Yes, it is. So I'm going to go ahead and open up Genie. I think of the way I'll do this. All right, there's my Genie. And now let's get a terminal together so we can actually start building the code. Okay, so cargo build. There we go. Cargo run. And you can see the hello world. Okay, we're all set. All right. So before we do anything, we have to create some variables that we're going to be checking. So I don't know, let's create some integers. We're going to be doing this with floats, integers. So let's go ahead and create a number of different variable types. All right, and let's put my signature program ending. Okay, so what is a match statement? Well, a match statement simply says I want to interrogate this variable, and if any of the values below match its value, then do something. That's a pretty good explanation. So I'm going to go ahead and give my first integer a value, and I'm going to do the match statement. So I'm going to say match and int1 with the value 0, the value 1, the value 55, the value 100, and I close it off. Now we're nowhere near ready to build this yet. There's some special characters. So if an int matches 0, that's the equal sign with a greater than sign, I want to just do something. I'm going to say int2 equals 0. If it matches a 1, I'm going to say int2 equals 1. I'm just doing something. I could do anything. I could even do a block, which we'll do later. I'm going to say int2 equals 55. If it's equal to 100, I'm going to say int2 equals 100. Again, so now I could specify any value in there, but the problem is that there'd be a whole lot there. But let's say I'm just looking for 0, 1, 55, or 100. What if it isn't any one of those? I'm going to put an underscore. Just like that. Now I have all these semicolons. I actually want to make these commas, or it's not going to build. And the very last one, I don't put anything. So, how would this look in an if statement? So I'd say if and int1 is equal to 1, do something. Else if and int1 equals 1, do something. Else, and you're getting the idea. So it is much more compact, but it's not as flexible, I think. Well, it could be as a if-else ifs, but we'll see some additional examples of this. Okay, so now I'm going to go ahead and say println value of int2 is. All right, let's save and build this. Okay, up. We're at an equal sign. And you can see value of an int2 is 100 because an int is equal to 100. So because an int1 matched the value of 100, it went ahead and assigned an int2 equal to 100, and then I printed it. Now I can go ahead and make this something that isn't in the list. So I'm going to say 6, and let's see what happens. And it's equal to -99. So you can see how the underscore, this is the default from a switch statement in C and C++. You could think of it otherwise, make an int2 equal -99. So it's not equal to 0, 1, 55, or 100. So kind of neat. Now, the other thing you can do is you can do also with floats. So I could do this with a float. So I could say a float 1 is equal to 103.45. And I'm going to go ahead and just copy this match and make my changes. And I'm going to match a float 1. And let's say I want... Now, let's just leave it like this, and let's see what happens. I do not believe it will build. It doesn't build. And the reason it doesn't build is because I need to use actual floating point numbers. So I need to do this. Just put... And let's see, instead of doing just assignments, I'm going to do a println. And let's put that we have to remember to put a comma. And then change it around a little bit. And just so you can see, we can actually put in real floating point values there. And then I don't need this last one here. Let's go ahead and save and build that. And it built. Let's go ahead and run it. And you can see the float value was unknown because I made it equal to 123.45, and none of these were selected. Let's go ahead and with 3.45, let's put a valid one in there. Save and build this. Now, I don't have to build it every time. I can just say run, and Cargo will know that the program has been updated, so it'll actually build it for you. And there it is. So it says the float value is equal to 123.45. Now, it's very important that you don't mix integers and floats with a match statement. In fact, I don't even know if Rust will allow you to do that. And the reason is because integers are processed in the CPU, the arithmetic unit of the CPU. However, floating point are processed in the floating point unit of the CPU. And they do things completely different. There might be some comparison issues. So that may be why. Let's go ahead and get rid of that 0.0 and see if... Yep. So Rust isn't even letting you do that, which is really nice because that doesn't happen in C or C++. So Rust is actually asking you to make sure you're comparing floats with floats and so forth. Okay, so that's a float. Now we can also do the match with a string. Now this is where the switch statement really falls behind the match statement, and that's because the switch statement does not allow you to compare strings. It only allows you to compare characters. So in this case, I'm going to say a C string equals, I don't know, Billy. And I'm going to say match a C string. And let's close it off. Don't forget to put that semicolon at the end. And I'm going to say I'm looking for Bill. I'm going to say Sue. And I'm going to put the otherwise. Now, just to be clear, I'm using the word string a lot here. This is actually a C string. It's just it's an array of characters. So let's see how that builds. It's not actually a string object. Oops. There we go. It couldn't compile. What did I do wrong here? Oh, I put semicolons. You don't put semicolons, you put commas. And the very last one, you don't put anything. There and built. Let's run it. It says unknown string value. Now I say here contains Bill. Even the word Billy contains Bill. So this is probably incorrect. So the string is not equal to. It's very important to word your messages correctly. Okay. Now let's go ahead and turn this into Sue. And let's see if that actually works. And it does. So the string is not equal to Sue. Oh, no, it is equal to Sue. Do you see why it's important to test? There we go. And so the string is equal to Sue. So it does a C string comparison just like the equals equals operator in an if statement. It goes one character at a time until it finds it. So that's how you can do strings. What if I want to put multiple lines of code here? Let's say I want to say print line. So if I want to create multiple lines of code, what you want to do is you want to put an open brace here. And you could put a semicolon and then say print ln line 2. You could do something like this. And then put a close curly bracket and then a comma. So let's see how this works. Okay, so it says Sue, but we didn't actually test the Bill part, so let's change this to Bill. And you can see the line 2 print. That print was the second one. Now, I think this is kind of bad coding, simply because if you've got like 20 lines of code, do you really want them to span the entire line and pass that? Probably not. So what would probably be a good idea would be to just go ahead and press enter there, put in some tabs. And you could even do something like this, which I very much like. Or even just line it up with that one. It's just style, however you want to do it. I don't know if you need a semicolon at the end here on the second one. Let's see if that will build, if it'll still run. And it does. So you can put a semicolon at the end. That's not actually necessary. You can just leave it as a without the semicolon because it's the last line. But I would really recommend that you do that just in case you want to add something in between, or if you want to add something after that. The semicolon is already there. So there's multiple ways of doing. I mean, it's just style, really. You can keep things lined up. I have a little bit of this problem, but I like things lined up just because it looks nice. I don't even like these like this. I like them lined up like that. It just looks nicer, gives me room to work, and just makes it easier to read. So just remember, you put a semicolon at the end of every line after the open and close brace. You're going to have a comma at the end of each close brace except for the last one, which is normally the otherwise. Now, do you need the otherwise? No, you don't need that at all. And the product or the code will build just fine. What did it do? Let's see what the error was. It says there's a problem on line 31. Because of this comma right there. So we took away the otherwise, and it looks like to ensure all possible cases are being handled by adding a match arm with a wildcard pattern. So yeah, so it doesn't like the fact, Rust doesn't like the fact that I didn't put the otherwise in there. So I'm just going to go ahead and put it back in, and now it likes it. So I kind of like that, right? Because you're being forced to put in the otherwise, the default in Switch, in C or C++. So I actually kind of like that. But you can have multiple lines per per match, I should say. Okay, what about multiple values? So I could say an int 2 or an int 1 equals 3. Then I could say match an int 1 with, I'm going to say 0 if it's 0. I'm going to say print ln. Now, what if I wanted to see if it's between 1 and 4? Well, I can't say 1, 2, 4. So I have to say 1, 2, 3, 4. Otherwise, and there you go. And you have to put the semicolon at the end. So let's go ahead and save and build that. And we have a problem. So 43, what are we doing? Oh, semicolons, semicolons, put a comma there, no comma there. It is different, the values between 1 and 4, because I made it equal to 3. So that's how you can select multiple ways. Now, I actually like that way better than the switch statement. On the switch statement, it's kind of cryptic how you do it. But anyway, so you can actually do that no problem by specifying multiple values. Now, I don't like the vertical line right up against each of them. And again, it's just style. You can see that it worked either way. And so now it works great. So that's the switch statement. Okay, another way of asking questions in your program. I said that's the switch statement because the match statement is much the same as the switch statement in other languages like C, C++. I don't remember if Java has it in it. I think it does. So, and the switch statement is something that came back from way back when. Way back in the 60s. 1960s. Not 1860s. I haven't been around that long. But it's very useful for menus. Like if you display a menu and you, instead of having a whole bunch of ifs, you can just have a match that selects every one possible menu option that the user typed in. And if they didn't type in a valued menu option, it's the otherwise clause. So very useful for that. Very useful for any kind of a number. Compared to C and C++, it's much more robust, the match statement, because you can actually use C strings in it instead of just single characters or numeric values. So very useful. Okay, we're getting there. We're getting done with the decision making. We're going to be doing a lot more decision making in upcoming videos as I show you how to do other things in Rust. So until then, take care.